A strong solar storm is a powerful burst of energy from the sun that can have significant impacts on Earth. These storms can disrupt communication systems, damage satellites, and even cause power outages. While Earth's atmosphere and magnetic field protect us from the most harmful effects, the technology we rely on is vulnerable. The science behind solar storms. The sun is a constantly active star, with its surface constantly changing and releasing energy. Solar storms are a natural part of this activity, occurring in cycles that last roughly 11 years. These storms can manifest in several ways. Solar flares. These are sudden bursts of energy from the sun's surface, releasing intense radiation into space. Coronal mass ejections, CMS. These are massive expulsions of plasma and magnetic fields from the sun's atmosphere. High-speed solar wind. These are streams of charged particles emitted from the sun, traveling at speeds faster than the usual solar wind. When these events are directed towards Earth, they can interact with our planet's magnetic field, causing geomagnetic storms. These storms can disrupt various technologies, including satellites. Strong solar storms can damage or disable satellites, impacting communication, navigation, and weather forecasting. Power grids. Geomagnetic storms can induce powerful currents in power grids, leading to blackouts and damage to transformers. Radio communications. Solar storms can interfere with radio signals, disrupting communication systems, especially those operating at high frequencies. Notable solar storms in history. Throughout history, several powerful solar storms have impacted Earth, some with significant consequences. The Carrington Event 1859. This was one of the most powerful solar storms ever recorded. It caused widespread auroras, disrupted telegraph systems, and even sparked fires. The 1921 geomagnetic storm. This storm caused disruptions to electrical systems, including power outages and short circuits. The 1989 geomagnetic storm. This storm caused a major blackout in Quebec, Canada, leaving millions without power for hours. The 2003 Halloween storms. This series of powerful solar flares and CMS disrupted satellite systems, caused power outages in Sweden, and even forced aircraft to be rerouted. The 2012 solar superstorm. This storm, while not directly impacting Earth, was powerful enough to have caused significant damage if it had hit our planet. Scientists estimate that it could have caused trillions of dollars in damage. The future of solar storms, as the sun continues its 11-year cycle, we can expect more solar storms, some potentially strong. Scientists are working to improve our understanding of these events and develop ways to mitigate their impacts. This includes space weather forecasting. Scientists are developing increasingly sophisticated models to predict solar storms and their potential effects on Earth. Technological resilience. Engineers are designing satellites and power grids to be more resilient to the effects of solar storms. Public awareness. Increasing awareness of the potential risks of solar storms and help individuals and organizations prepare for potential disruptions. Solar storms are a natural phenomenon that we need to understand and prepare for. By improving our knowledge and technology, we can minimize the risks and ensure that our technological infrastructure is resilient to the impacts of these powerful events.